Hello everyone. Today we're going to be learning about vectors and matrices. So, as we all know, MATLAB stores data in groups of one or more items. These are known as arrays. And these variables can be stored in different sizes. Now, what does it mean to have a size? The size of a variable, or an array, is the number of rows and columns that it has. So, the three types of arrays that we have are matrices, vectors, and scalars. So matrices are two-dimensional, meaning they have both multiple rows and multiple columns. We have an example here of a 3 by 3 matrix with the rows pointed to in blue and the columns pointed to in red. It's 2D because it expands in both directions. A vector is a one-dimensional array. It either has multiple columns and a single row or multiple rows and a single column. So one with a multiple columns and a single row is known as a row vector. One with a single column and multiple rows is known as a column vector. These are illustrated here. And lastly, we have a scalar. It's not one-dimensional, it's not two-dimensional. It's just one by one because it doesn't expand in either direction. And here we have one row, one column. So one thing to note is that a scalar is a matrix and a vector is a matrix. But a matrix cannot be a vector or a scalar, and a vector cannot be a scalar. It's sort of like the square rectangle rule, but here we have a little diagram to illustrate how these types of arrays are subsectioned. So we have a subset of matrices that are vectors and a subset of vectors that are scalars. So this means that since they're all classified as matrices, they are compatible with the same arithmetic operations if they're performed at an element by element basis. So element by element basis means that you are taking each element of the first matrix, each element of the first matrix, and you're operating it with this equal, with the corresponding element of the other matrix on the other side of the operand. So let me get into some detail here with some common array operators. So first we have addition. So this addition, subtraction, multiplication, and division, and exponentiation, these all work in two cases. A, if the matrices that you're multiplying, adding, subtracting together are the same size, or if the second one if the one of the matrices is a scalar. So for instance, we have addition. So the first option that I just discussed, we have two 1 by 3 matrices being added together. So the 1 gets added to the 4, the 2 gets added to the 5, the 3 gets added to the 6 to give us this matrix here. Here. And the other way you can do it is use a scalar with it. So the 4 in this case will get added to each element of the first matrix. Same thing applies with subtraction, except you're just subtracting them. So 1 minus 4 is -3, 2 minus 5 is -3, or we have 1 minus 4, 2 minus 4, 3 minus 4. So now with multiplication, division, and exponentiation, to do it on an element by element basis, you have to use the period before the operand. This indicates that you're taking each element. So let's say the 8 gets multiplied by or divided by the 4, or like your 2 above here gets multiplied. The 2 here gets multiplied by the 5. So basically saying take each element and use it with the corresponding element of the other matrix. If you didn't do this, it would try to do matrix multiplication, in which case you'd need like one column vector or one row vector and one column vector multiplied together in order for it to work. Matrix multiplication is not what we're getting into today, but just know that you have to do the period before so that it does it element by element. And lastly, we have transpose. So what transpose does is it takes each element of the matrix and it switches its row and column index. So for instance, the 1's going to stay the same because it's 1 by 1, or 1 comma 1. It's in the first row and the first column. Whereas here we have 5 down here. So this 5 is going to be moved, since it's in the second row, second column, it's going to be moved second row, second column. Here we have, let's use a better example. Here we have this 3. This 3 is going to be moved, since it's in the first row, third column, it's going to be moved to the third row, first column. So basically, you're taking all your first row, making it your first column, you're taking your first column, making it your first row, and so on. Thank you so much, and next we'll get into indexing.